Season 1 of Full House, Uncle Jesse told us that rules are meant to be broken. And although I tend to agree with him more often than not because he was cool, in this case, I can't agree with him. You see, when we learn in the last section is that there's shortcuts to taking derivatives. You don't need that limit wackiness anymore. I can just, if I have an exponent, bring stuff out front, subtract one from the exponent, bada bing. But if I'm multiplying two functions together, as you can see here, or if I'm dividing functions together, like if I were to say that guy divided by that guy, am I just allowed to take the derivative of every term and leave it as is? No, I'm not. And that's what the product and the quotient rule are for. The product and the quotient rule are rules that tell you what to do when you're dealing with two functions multiplied together or a function divided by a function. First thing that you're going to see is the product rule. I have one option. If I were to ask to take the derivative of that, if I were asked to differentiate that, I can FOIL it out and take the derivative of the terms. Easy peasy. But what if I have something worse? Or what if I don't want to do that? Or what if you can't FOIL things out? You have the product rule. What you do is you label one of those factors or one of those parts. You label it U. You label the other one V. You take the derivative of U and multiply it to V. Plus, take the derivative of V and multiply it to U. So I think I probably just end up doing this problem anyway, so I don't want to do too much. But I would call this guy U. I would call this guy V. I would find out what U prime is. I would find out what V prime is. And then I would plug it into this formula right here, the product rule. Okay, product rule is pretty not bad. Quotient rule is worse. But we're going to spend this entire section just doing a bunch of problems that use either or use both. And in some cases, we will use maybe a product rule twice or a product and a quotient rule in the exact same problem. So when we get to that, we'll get to it. All right, here we go. We're going to start out by doing the product rule. As you can see, that's the product rule right there. You are taking the derivative of something times something. Now what I could do here is I know I can multiply 3 times 2 to get 6 and get x cubed, and I know that I'll get 27x squared as an answer, but this is just for practicing the product rule and proving that, it does work. It actually would be 18x squared. I'm so very sorry that I said 27. I'm just so bad. Just thinking of my age in a few years. All right, so let's let U be that. I'll say U is that, V is that. So U prime is going to be 6x. V prime is going to be 2. So the derivative is going to be, so we'll say f prime of x is going to equal u prime v plus v prime u. And what that looks like is 6x u prime times v 2x plus v prime 2 times u, which is 3x squared. 6 times 6 is 12. X times x is x squared. 2 times 3 is 6. X squared is x squared. Add them up. And just as I predicted, oh my goodness. Predicted the second time around. Cool. Lit. Let's do it again. I can FOIL if I wanted to. And every time I FOIL, I have to remind myself that it's not the first time I FOILed, so it's a curse that I FOIL again. Curses, FOILed again. Let's call U. Let's call U V. U prime is going to be, and I'll put it in parentheses because I have several stuff going on in here, 3x squared minus 2. And V prime is going to be 0 plus 8x cubed. So y prime is u prime v plus v prime u. I'm spacing it out a little bit here so I can show a little bit better. U prime was 3x squared minus 2. V was 4 plus 2x to the fourth. Plus v prime is 8x cubed. And u was x cubed minus 2x. Got ourselves good old FOIL. So I guess I do have to FOIL. Curses, FOIL again. Foiling it again. 12x squared plus 6x to the sixth minus 8 minus 4x to the fourth. This is just regular distributive property. Plus 8x to the sixth minus 16x to the fourth. Let's see what like terms I've got here. Let's start with the biggest. Let's start with u. 14x to the sixth. Got u, babe, minus 20x to the fourth. And then plus 12x squared minus 8. Let's ramp up the difficulty a smidge. We've got u prime v, product rule. ddx of uv is u prime v plus v prime u. If you're wondering which one has to be u and which one has to be v, it doesn't matter because we're just saying the derivative of one function times the other function plus the derivative of the other function times the one function. So don't worry about what's what. Don't be like, oh, the left one always has to be u. It's not going to matter. I mean, I could write this out as v prime u plus u prime v. Doesn't matter. It doesn't matter at all. So that's my u and that's my v. U could be rewritten as x to the 1/3. Cube root could be rewritten as x to the 1/3. So that's going to make u prime equal to 1/3 x. And then when you subtract 1 from a third, you get negative 2/3. So I can write that out as 1/3x to the 2/3. That's what u prime is. V prime is 1. So easy, and then the other one not so much. F prime of x is u prime v, so I've got 1/3 x to the 2/3 on the bottom times v, which is x plus 5, plus v prime, which was 1, u, which is cube root of x. So just to stay consistent, x plus 5 stays on top because it's multiplied to 1. 3, I don't like my exponents as fractions, so I will turn that into the cube root of x squared. It doesn't matter if you leave it like that. This is just a personal choice, and I'm allowed to have it, so please, 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 how dare you discriminate. And 1 times the cube root of x is just the cube root of x. Let me get you some space here so you can see the whole thing. I don't want a piece of you. I want the whole thing. Happy Gilmore. Bob Barker said that. I think he's still alive. If he's not, rest in peace, my guy. Let's rewrite u literally as x to the negative third. So that would make u prime equal to negative 3 x to the negative fourth, or negative 3 over x to the fourth. That's u prime. V prime is 3x squared minus 0. Dy dx or y prime, or however you want to write it out, is going to equal u prime v plus v prime u. So u prime was negative 3 times x to the over x to the fourth rather, times what was v? X cubed minus 9 plus v prime, which is 3x squared, u, which was 1 over x cubed. A little bit of cleaning up to do. Looks like there's going to be a cleanup on aisle 5. The Office. I quote movies a lot. So I have negative 3x cubed. What was that? A minus 9? Yep. Plus 27. What did I do? I brought that up top and I distributed the 3 to both of those guys. The negative 3 because there's a negative living out front. Although I could have kept the negative outside. Too late. Can't stop me. And on the bottom I have x to the fourth plus 3x squared over x cubed. Get rid of that, and I get 3 over x. Don't worry about combining those fractions. No need. Well, there's the age-old question. If we can differentiate two functions multiplied together, could we differentiate two functions divided, one divided by the other? Is it possible? Well, here we have two functions multiplied together. We have a fraction times a binomial. Normally, we would use the product rule. We would call that u, we would call that v, and then we would take it from there and plug things in and yada, 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 yada. But what if I wrote that out to look like that? I mean, what if I multiplied the x cubed minus 9 and put that up top here and still had the x cubed on the bottom? I mean, those are the same thing, right? I mean, multiplication and division are basically the same process. It's just when you divide, you multiply a reciprocal. So they're the same thing. They're the same thing. So there has to be a rule for when you divide things. There has to be, I don't know, let's call it a quotient rule. And there is. Similarly, we would call the numerator u. And we would call the denominator v. And the quotient rule would be u prime v minus v prime u, so almost the same thing, over v squared. Now, there's a typo in the notes where I accidentally put u, so I seamlessly wrote a v there. But that's the quotient rule. The quotient rule is if you don't feel like turning a guy like this and ripping it apart and making it product rule, which, you could if you want to. You could call that x to the negative third. There's also the quotient rule, and sometimes it's just more convenient. Most times it's more convenient to just use the quotient rule, which is how we're going to approach the next several problems. So, again, you take u, you take v, you find u's derivative, you find v's derivative, you take v and you square it, you find that as well. You throw it all together, do some simplifying, hopefully things disappear, and you end up with the quotient rule. All right, so let's practice a few of those. All right, so there's the quotient rule. Again, that's supposed to be v squared, seamless. I'm going to do A. I'm going to move it up here. I have all this space, so I'm going to use that space for letter A up there. I'm going to call U. Make sure that you can see it. I'll move that down so you can. U is going to be x cubed minus 9. V is x cubed. U prime is 3x squared minus 0. V prime is 3x squared. And v squared is x cubed squared, which becomes x to the 6th. Multiply exponents. So y prime or dy dx, let's call it dy dx this time. I'm feeling adventurous. Dy dx is going to equal u prime v minus v prime u. So u prime is 3x squared. V is x cubed minus v prime u. So v prime is 3x squared. U is x cubed minus 9 over v squared, which is x to the 6th. Make sure you can see it all. So that first term here multiplies out to be 3x to the 5th. Add the exponents. Distribute minus 3x to the 5th plus 27x squared. That's going to be over x to the 6th. These guys perfectly disappear. 27x squared over x to the 6th. I have a bunch of x's upstairs. I have a bunch of x's downstairs. The downstairs is more powerful. So you subtract exponents. Lots of algebra 1 coming back to haunt us. You get 27 over x to the 4th. Trying to remember if we did, because when I record this, sometimes I record it over a span of a few days, and I'm trying to remember if I recorded this exact one yesterday. And if you're wondering, is he digging through his trash just to see if you can find the answer for us? I am. And I can't find it. So yeah, I don't know. I'm sure we did. I'm sure we did. All right. Let's take a look at B. That was A. Here's B. All this space to dance around, and I'm going to need all of it. All right. Here's my U. Here's my V. U is root x. So I'll change it to x to the 1/2 right now. Minus 3x squared. V is x minus 1. U prime has me pulling the 1/2 out in front of x and turning that into the negative 1/2, which turns that into 1 over 2 x to the 1/2. And since I left that like that, let's leave that like that and see what happens. And then in the end, we'll fix it when we have to. We'll turn it into a square root when we have to. I'm leaving it like that just in case it might appear to be more convenient. Let's keep going with the blue. V prime. Look at that, is 1. That's nice. V squared is x minus 1 squared, which is a perfect square trinomial. So that becomes x times x minus 1x minus 1x plus 1. So there you have it. That's h prime of x is going to equal u prime v. So u prime was 1 over 2x to the 1/2 times v minus v prime u. V prime was 1, so that's convenient. And u was x to the 1/2 minus 3x squared over v squared, which ended up being x squared minus 2x plus 1. I have a feeling I might want to come back to that form of it. But we're going to do a lot of simplifying here. I want to, since we have all this space, I want to get the entire answer down. All right, so this becomes x minus 1 over 2x to the 1/2 minus, and this is what I'm going to do. I'm going to start writing this out as a fraction. Okay, x to the 1/2 minus 3x squared. I'm going to multiply the top and the bottom by 2x to the 1/2, 2x to the 1/2, all over x squared minus 2x plus 1. That ends up being x minus 1 minus 2x to the 1/2 times x to the 1/2, add the exponents is 2x, minus plus 6x to the 5/2. That's going to be all over 2x to the 1/2. All over x squared minus 2x plus 1. Going to move that over there. This becomes negative x, so I'm going to reorganize things. 6x to the 5/2. These guys combine to make negative x minus 1. Over 2x to the 1/2. And what I'm going to do is I'm going to set that guy over 1 and multiply this guy by 1 over, not 1 over, 1 over x squared minus 2x plus 1. That becomes 6x to the 5/2 minus x minus 1. Distribute that. Add the exponents, so 2x to the 5/2 minus 4x to the 3/2 plus 2x to the 1/2. And let's just clean that up with the halves and call it a day. Boy, talk about a situation where you have the haves and the have-nots. Am I right? 6 square root of x to the 5th minus x minus 1 over 2 square root of x to the 5th minus 4 square root of x cubed plus 2 square root of x. Gross. Gross. Two very unpleasant problems. Well, no. I take it back. The very first one was pleasant. And I seem to remember us definitely doing this problem when I recorded it yesterday. And the answer not being super convenient, but this time it was. Now, this problem was just awful. Awful. So if you left it like that, I'd be okay. If you left the answer like that, I guess I'd be okay, but I wouldn't be too happy with you. It's just, if you want to really make me happy, you always leave the answer like that. Do as much as you can. I mean, if the Lord expects it out of you, I expect it out of you too. Right, gang? Okay. So, I have the product rule. And the product rule states that if I take the derivative of something times something, it becomes u prime v plus v prime u. What about something times something times something? Well, don't overthink it. How about you just use the product rule twice? Which I will do. So in situation number 1, I'm going to let u equal this. I'm going to let v equal that. So you ready? U prime is -1. V prime is, I don't know, V prime is going to be that times that. So don't I need to use the product rule for that times that? I sure do. So V prime is going to involve me coming off to the side here and saying, all right, well, hopefully that's enough space. 2x squared plus x minus 1, 4 plus 2x cubed. That's my u. And if you want to use different letters to avoid confusion, that's not the end of the world. I always use u and v. And since I'm off to the side, I'm kind of differentiating, differentiating that from that. So that's my u. U prime in this case is going to be 4x plus 1. V prime in this case is going to be 6x squared. So in this case over here, u prime v is going to be 4x plus 1. V is 4 plus 2x squared, cubed, plus v prime is 6x squared. U is going to be 2x squared plus x minus 1. Remember, all of this is v prime for the original problem over here. So again, if you want to use different letters like W and X, or maybe not X because you have X, but U, V, W, Y, it doesn't really matter. It really doesn't matter. All right, FOIL. 16x plus 8x to the 4th plus 4 plus 2x cubed. Distribute, right? Yep. 12x to the 4th, 6x cubed minus 6x squared. I'm sure I can combine like terms here. Boom, boom. 20x to the 4th. 2x cubed, 6x cubed, 8x cubed, minus 6x squared, plus 16x, plus 4. And that, boys and girls, is v prime. So what was v prime? All the way over here. 20x to the 4th plus 8x cubed minus 6x squared plus 16x plus 4. All right, so now that you're out of the way, I don't have to deal with you so much. I have u prime as that. I have v prime as that. So u prime, so y prime is going to equal, that says y prime is going to equal u prime v. U prime was -1. V was 2x squared plus x minus 1, 4 plus 2x cubed, plus v prime 2x to the 20 x to the 4th plus 8x cubed minus 6x squared plus 16x plus 4 u 3 minus x. negative 2x squared minus x plus 1, 4 plus 2x cubed, plus, are you ready? 60x to the 4th minus 20x to the 5th, 24x cubed minus 8x to the 4th minus 18x squared just making sure I'm at the right spot, plus 6x to the 3rd plus 48x minus 16x squared plus 12 minus 4x. Cool. Now I have to FOIL this. I'm just going to write it all out just for funsies. I love having a good time. Negative 8x squared negative 4x to the 6th, 5th. Oh, that could have been a disaster. 5th minus 4x minus 2x to the 4th plus 4 plus 2x to the 3rd plus, let me be cute here. Do any of these combine? No. So this is what I'm going to do. 60x to the 4th negative 20x to the 5th 24x cubed negative 8x to the 4th negative 18x squared 6x to the 3rd 48x plus there minus 16x squared plus 12 minus 4x. So all that's going to equal negative 8, negative 18, negative 16. We have negative 26, negative 42, right? Yeah, negative 42x squared, negative 24x to the 5th, 40x, 50x to the 4th, 16, and that's 26, 32x cubed. Last but not least, now there's multiple ways that I can handle this problem, but just for example's sake, all right, I'm going to combine product rule and quotient rule. If I wanted to, I could, distribute that to the top and not have to worry about product rule. But the purpose of this example, along with the previous example, is although I don't have to use these rules twice in the same problem, it's possible. and I want to show you how it's done. So that's what I'm doing. So it would make sense to me to call that U and call that V. So I'm using the product rule first. So the product rule says that ddx of uv is going to be u prime v plus v prime u. So according to this guy, I have u, I have v. U prime is going to be -4. And v prime is going to be quotient rule. So like we did. All right, well, like an idiot, I knocked over my webcam, which caused my computer to restart, and 15 minutes later, I could finally finish this problem. So I don't even remember what I said before I knocked my webcam over. Not webcam, but document camera. All right, so I let that be U. That's where I got -4 from. I let that be V. And so what I have to do is I have to do quotient rule to find out what V prime is. So I have all this space up here. Let's put V prime there. V prime is going to involve me using the quotient rule. So let me rewrite out the original thing. I have x to the -4th plus 2x. That's going to be my U. My V is going to be, I'll put x to the 1/2 because chances are I'll have to deal with that. Okay, u prime is going to be -4x to the -5 plus 2. V prime is going to be 1/2 x to the -1/2. Bring the 1/2 out front, subtract 1 from 1/2 to get -1/2, and I'll rewrite that out as 1/2x to the 1/2. And v squared is going to be the square root of x squared, which is x. So just a reminder, quotient rule is u prime v minus v prime u over v squared. So that ends up being u prime, I'll write it underneath, u prime was -4x to the -5th plus 2 times v, which is x to the 1/2, minus v prime, which ended up being 1 over x to the 1/2 times u, which is x to the -4 plus 2x, all over v squared, which is x. I'm going to need a ton of space for this one. Probably going to need all that space. All right, so boom, boom. Add the exponent, so I have -4x to the -4.5, so I'll put 9/2 plus 2x to the 1/2 minus, this is how I'm going to handle this one. I'm just going to pretend that that's, the 2's on the bottom, I'll keep it on the bottom. I'll write it out like this. 1/2 x to the -4 minus 1/2, which is, oh, no way, -9/2. Okay, that's good. Plus 2/2 is going to just be 1 x to the 1/2. That should be minus because I'm distributing the negative here. Distributing the negative, distributing the negative. That's a minus. What I'm going to do, oh, all over 1/2, all over x. So a lot of simplifying here, which is convenient. -4.5 x to the -9/2. plus x to the 1/2 over x. And what I'll do is I'll go one step further and divide everything by x here. So I have negative 4.5 x to the negative 11 over 2 plus x to the negative 1/2. I'll leave that like that. I'll leave that like that for now. And I'm sure I'll change it later. All right, back to product rule. U prime V plus V prime U. U prime is negative 4. V was that monstrosity. Didn't I already change that? And I'll change it again. Negative 4 times, yeah, I'll do it now. X to the negative 9 over 2 plus 2x to the 1/2 plus V prime, which is negative 4.5x to the negative 11 over 2 plus x to the negative 1/2 u, which is negative 4x. So I have negative 4 times x to the negative 9 over 2 minus 8x to the 1/2 plus, actually minus 18 x to the negative 9 over 2 minus 4x to the 1/2. These guys are the same. Negative 22 x to the negative 9 over 2. These guys are the same. Minus 12x to the 1/2. And last but not least, I'll just simplify it out. Negative 22 over the square root of x to the 9th. Minus 12x, root x. On the fun factor scale, this would rate low. But we did it. And I believed that we could. This whole time, I believed that we could. So that is done. It is finished. All right, that wraps up this section called Power Rule and Quotient Rule. The next rule is the Chain Rule, baby. Bye.